Welcome to our podcast. Today we've got Brad, and we're going to be discussing manufacturing, robotics, AI, and the implications for both the manufacturing industry and society as a whole as we go into the next phase of the Industrial Revolution by putting the changes in the manufacturing industry of more AI and robotics. Brad, welcome to our podcast.
Thank you. It's great to be here. I'm quite excited.
Brad, we're seeing such a transition, and we initially saw that the use of robots were very stationary, static in their approach, and did a lot of repetitive actions. But the manufacturing environment generates a great deal of data, much of it dynamic, and the patterns in the data themselves evolve over time. So we've seen a great influx of the use of AI. And what I've seen is that AI is shifting us from not just providing digital displays of data summaries or metrics, but actually moving the manufacturing environment into the next stage, which is more about the recommendations based on that data. So back in the day, we would have a digital display. Operators could see the sensor results, the metrics, but what I've seen out there in the manufacturing environment is much more around artificial intelligence being able to provide the recommendations and then also being able to implement them. And I'm wondering if you can give us quickly a sense of the state of the art for artificial intelligence, robotics in the manufacturing field. Where are we going over the next couple of years with that? And what's the impact on society in terms of where those manufacturing jobs will take place? Is this we're now entering an era in which the cost effectiveness is to the point in which we'll see more onshoring?
What I'm seeing is that there is
Well, we're seeing a lot of changes. I've seen some startup companies, for example, that are focusing on that data analytics, and they provide hardware and software solutions so that when the manufacturing operator can be anywhere, they can be off in the cafeteria and following the data patterns as they evolve. And you must be seeing in the manufacturing and the robotics area this fusion of data and machine sensors resulting in knowledge through AI that's changing the way we make decisions.
Yeah, I believe there is a bit of that, and that is happening, but I don't see it as accelerating from, I see it as a historical trend. A lot of these innovations that we're seeing now are actually older than what we think. For example, there's a lot of attention focused on robotics. However, the first industrial robots was made in the 1960s. And a lot of these factory control systems, they date back to the early 1900s. And there are control system logic programming methods that still harken back to those days 120 years ago.
And even with these older style systems, the data, of course, is revolutionizing the way that the manufacturing environment is making those decisions. What is it then that you're seeing that is changing the environment with the fusion of these different technologies? How are we shaping out the manufacturing environment over the next, let's say, 5 years?
One way that I believe is going to be shaping out is, okay. One way I can see it shaping out is the advanced levels of the one way I could see this shaping up is the more data that we have, the more products we can produce. We're able to now take a lot of customer inputs and really create more personalized products. So instead of having a generic product, we can now retool assembly lines and manufacturing systems a lot quicker and easier, so that we can, sorry about that, we can now get more personalized products.
Brad, is this, are you referring to maybe using something like additive manufacturing approaches?
Additive manufacturing is going to, I believe, additive manufacturing, I believe, is going to be a part of this in the future. I've heard some say that it's going to completely displace current methods of manufacturing. However, at the moment, I'm not quite seeing that. What I'm more seeing is that it adds certain abilities that we currently don't have. And actually, the main benefit of additive manufacturing at the moment is being able to churn out prototypes very, very quickly. And another benefit for manufacturing is being able to churn out very specialized parts. A good example of this is with some of the car companies, such as some of the car companies that have lines going back many decades and would be considered classic cars. So these be like Mercedes, BMW, and what they're starting to do is they have all these parts, library of parts for cars that they've been making since the 30s, 40s. They still have those drawings, but there's not enough of those cars around to justify the tooling expense of an assembly line or a manufacturing process. So what they'll do is use additive manufacturing to make these classic car parts in batches of a dozen, and then they can supply the classic car market. Another thing that I'm seeing, just going back to data and stuff, is there's a security aspect associated with this. Is the security aspect. The classical method of securing your assets against unwanted intrusion has been through the use of what's called an air gap. And an air gap is basically, you can't hack what's not connected to the internet. If the only entry point is a couple of buttons at the plant, it's darn near impossible to cause any problems with that plant. And the problem that we've had with a lot of this data is a lot of it's come from industrial Internet of Things or Internet of Things. So think of the best consumer example would be, that people would be most familiar with, would be smart home technology. So being able to unlock your door, let your dog out, letting in the Amazon delivery person into your front entry so that your packages don't get stolen off your doorstep, that type of thing. And there's a lot of data coming in from those type of systems. So that's IoT. Industrial IoT is where they connect these sensors, connect them up to the internet, to the cloud network, and that's how they're getting a lot of the data in. And the problem with that is that now you're connected to the internet, so now you're exposing your plant to the same threats as a computer PC would be threatened with. The problem being is that if your PC goes down, and I've actually been hacked and I've seen this happen, when my PC went down from a hack, I went to a computer repair store and they repaired it, and I lost maybe a half a day of time. The problem with industrial plants is, since they're connected to, industrial plants are connected to physical moving things. So instead of software going down, now it's hardware going haywire and very powerful machines. And that has a capability to hurt a lot of people very quickly. Another problem, and so the problem with that is that there's been a lot of products enter the market that have not been as secure as they should have been. And they're finding ways that they're being exploited, especially if you're not careful. The earliest example of something like this happening was in the early 2000s when the Iranian nuclear facilities were hacked so that they couldn't produce any nuclear components. I believe it was enriched uranium. They couldn't produce their instruments were programmed to give false readings. Nobody knows who did it, but that was the first example of it. The scariest one actually is a plant in Saudi Arabia, an oil plant with a lot of hot oil, a lot of pumps, a lot of moving machinery. And there was a group that had infiltrated the plant through the internet, hacked it over a period of 4 years. And what was very, very frightening about that was when they hacked the plant, they got into what was called the safety instrumentation systems, which are the last line of defense. If something goes wrong, those are the systems that shut the plant down. Those are the systems that stop anything bad from happening. And those were compromised. So if these hackers decided to do something bad, they could have gotten away with it. And they could have caused a lot of damage and most likely loss of life if they wanted.
Brad, it seems that if I was going to try and hack into a manufacturing facility, maybe it might be a better approach might be a little more subtle. For example, just to change the configuration of the machines a little bit so that they're not quite as efficient. Maybe they're using more power, maybe they're just a little slower, and yet at the same time on any of the digital displays make it look as if the metrics are all just fine. So they're all within normal parameters, and yet the machines are just some small percentage less efficient or less effective in some way. That might take some time to be able to recognize, because if the data displays are showing with normal parameters and yet the machines are not actually operating within that, if you take a large manufacturing facility, that can be significantly millions of dollars lost.
And that's exactly what happened in terms of, that's exactly what happened to the Iranian nuclear plant. That's what happened. The centrifuges, which is a component that was used to make the nuclear fuel, was programmed to spin a little bit faster to throw off the settings such that from an operator's naked eye point of view, they would see that everything was working all right, everything was spinning the way that it should. But the quality of fuel coming out was drastically lowered. And it took a while for them to recognize, because they started getting these products, these substandard products, further downstream in the manufacturing process of this nuclear fuel. And that's when they noticed, and then they went back. In terms of the plant in Saudi Arabia, it took them about 4 years, they figured, until they found out. And they found out because one of the hackers was sloppy. So yeah, it can take a lot of time to do.
Well, I can imagine even recognizing the problem takes a while, but trying to diagnose it with all the complex set of variables and the correlation between them, trying to figure out cause and effect, and particularly if the metrics that we're seeing on the digital display, and we're relying on those, all apparently seem to be within normal operating ranges. I can imagine the complexity of trying to figure that out detecting it within that 4-year time frame, because the hacker was sloppy, was a lucky break. If they had to detect that and then figure it out themselves, wow, they could have been all kinds of lost in a profit manufacturing environment, lost millions of dollars. So this security and the protection of the data in the manufacturing facility is problematic from your description, and obviously it's a well-known issue. Is it just a simple matter of the normal IT kind of security protections that we put into place around hacking? Because it sounds as if the detection of the problem is more difficult. So it's not just the same as we would do on a PC of putting a firewall in place or having some virus checker. It's because the issue is more complex of actually detecting the problem itself. What's happening out there in terms of that ability to detect and diagnose?
What I believe is happening is that they are using a lot of this data and finding better ways to process this data, so that if there's a problem, then you're immediately notified of it, as well as the same basic things that have been done for centuries. Operator vigilance. Operators would go, at least I've seen this in some large plants, oil sands manufacturing plants in Alberta, is that operators would walk around these plants just to make sure that everything's all right, that nothing's out of place. And these guys are in these plants on a regular basis. They know everything that goes on with them. They're very, very good at what they do. And their intuition can generally tell when something's a little bit off.
That also sounds like a role for artificial intelligence to be able to determine based on the patterns in the data when something is not within the parameters, and also to figure out the cause of it amongst all the different correlated variables.
Yeah, that is something that artificial intelligence can do. And in this case, artificial intelligence would be sort of an upgrade compared to the programs that are already in place. A lot of these factories are very instrumented. They've got a lot of control systems in place, a lot of logic controllers, everything in place. What I see artificial intelligence doing is, I see it as a natural outgrowth from a lot of the information that these plants are now carrying out. And I see that as an outgrowth of a lot of the information, and being able to add an extra layer of processing and detection. I think that it's not radically different from the programs that they already have. It just adds another method of insight.
Brad, as we come to the end of our podcast, do you have a quick takeaway, something that the users can implement or action? Certainly, artificial intelligence itself and the use of it around the detection of patterns in the data sounds quite intriguing.
Oh gosh, I'm trying to think of one, but...
Well, maybe we can leave it at that. That's an interesting takeaway, is the whole security side and the detections and the subtleties that hackers can put into the system to put it off its track, and yet it's difficult to detect, so that the IT security and the role for artificial intelligence, those are interesting takeaways.
Another takeaway is that even though artificial intelligence another takeaway is that even though computer systems such as artificial intelligence and industrial Internet of Things and advanced systems of okay, let's try that over. Good. One takeaway is that even as we develop advanced computer systems and continue improving ways of getting information into these computer systems through various sensors, is that at the end of the day, we still need the human touch with these plants. We still need people to figure out, to use their intuition to know when something's wrong.
Okay, good stuff. That's the end of our podcast. Thanks for joining us today, Brad.
Yes, thanks for having me.